Hello, in this video we are going to continue our discussion about radical graphs, and as you can see here I have looked at this function f of x, and since we have a square root function we know that x plus 3 has to be greater than or equal to 0, which means x has to be greater than or equal to -3, and this is going to tell me my domain of the function. So when I pick values in my chart, I want to make sure I am picking values that match the domain. So you can see the smallest x value that I need to use is -3, and I have then plugged this into the function, and I got an output of -1 and then plotted that point. Then I chose other x values that I can plug in to give me nice neat numbers that I can take the square root of without getting a decimal. So -2 works well, and you get an output of 1 when you plug that in. 1 gives you an output of 3, and 6 gives you an output of 5. Now you will see that you can use other x values if you want to. You're just going to get decimals in your output, which are a little bit harder to graph. So I suggest trying to use x values that will make your life easier instead of more difficult. So as you can see from the graph, once we plot the points and fill in the curve, you can then see that your range is clearly going to be -1 to infinity with a bracket on the -1. So what they're doing down here is leading you through some questions to get you thinking about some concepts that are important. So they're saying draw a horizontal line of y equals 2 through the graph. So if we do this, let's see, I'll pick a color here. If we do this, we're going to have a horizontal line coming through right through here. Okay, and then it's saying, hey, does that intersect the graph? And yes, it does. And what is the value where that intersects the graph? So it intersects about, let's see, right in here-ish. Okay, and then you want to think about the coordinates of that point. And you're just approximating here. It's okay if you're having to guess a little bit. So on the answer key they say that it's -0.75 and 2, obviously 2 because of the y value. But if you were guessing a different x value right here, that's fine. It's like I said, you're just trying to approximate as best as you can from the graph. Let's see, actually I wrote this in the wrong spot, so let me get that straightened out here. Alright, now if we go down to this next part, they're saying draw a line of y equals 1. So we'll pick a different color and draw that. So that's going to come across, oh, it's kind of thick there, huh? Come across at the y equals 1. And then you're looking, where does that intersect your graph? And since that was a point that we actually plotted, all right, we have that point in our table of values, we actually know that that is an actual point. We don't have to guess. -2, 1. All right, and then if you go down to part C, it says draw a horizontal line of y equals -2 through the graph. Well, when you go down to -2, that's down here, and you can see that that's below the graph. So that does not intersect at a y value of -2. So you can say no solution here, no solution, or no intersection. And then lastly, if you look at part D, it says draw a horizontal line of y equals 5. Well, that's going to be up above. So let's see, we'll use this pretty color blue here. So 1, 2, 3, 4, 5 up in here. And once again, that is actually a value we used in our chart, right? We had a y value of 5 when we used an x value of 6. So we know that that's actually the 0.65. So essentially what you're seeing here is that when we use certain y values, we were able to get a solution point or intersection point, and then when we use a different y value here, the -2, it did not intersect. So this is actually an important concept that leads us into the solving of the equations, and is saying, hey, if a y value of b, okay, is in the blank of the function, then there is at least one x value in the blank. So what they're looking for right here is range, okay? And so if your y value is in your range, then you're going to have at least one solution, okay, in that domain. All right, so let's go back up here and I'll show you what I'm talking about. So when we used a y value of 2, that is in our range, okay? So I know I'm going to get a solution point or an intersection point. When I have a y value of 1, once again, that's in the range. So I know I'm going to get an intersection point. However, when we used a y value of -2, that is no longer in our range, right? -2 is further negative than the -1, and our range starts at -1. So that's not going to give us a solution because it's not in the range. And then lastly, y = 5 was in the range, so we were able to get a solution point. So as we go into our solving of the equations, you will see that sometimes you are going to get no solution for these equations that we're solving. And when you get no solution, it has to do with this, okay? So when you have a value in an equation that does not match the range, you are going to get a no solution because there is nothing in your domain that can give you that output. So just be on the lookout for these no solution, okay, that are coming down the line when we do our algebra, and I'll see you in the next video.